This is the final of a series of 3 ShowMes introducing methods for solving systems of linear equations. The first of these 3 introduced the graphing method. The second introduced the method of substitution. And this one's going to introduce the method called elimination. As the word elimination suggests, we're going to get rid of some things in an effort to make the problem simpler. In fact, if you've checked my blog recently, the concept is like that of setting the dumpster on fire. No, we're not advocating arson. The idea is we're going to take a problem that seems complicated and we're going to try to turn it into a problem that we already know how to solve. And if you want to know what the expression setting the dumpster on fire means, check out my blog. So here we have 2 linear equations in 2 variables. And you'll find that the elimination method is ideally suited to the linear equations written in standard form. That is, ax plus by equals c. And both of these linear equations are in that form right now. The elimination method has as its focus the idea of eliminating one of the variables so that we can solve for the other one. In a sense, then, it has a lot in common with the substitution method, which accomplished a similar task. After making the substitution, there was only one variable left in the equation. What we're going to do now is demonstrate how to make one of our variables go away. If you take a look at these 2 equations, you realize that 6x and negative 6x are opposites. How can I use that to my advantage? Well, there's this wonderful thing we've talked about earlier in the Algebra 1 course called the addition property of equality. And it says that if you add a number to one side of an equation, you must also add it to the other side of the equation. Well, the beauty of that particular rule is that the 2 things that are added simply must be the same number. They don't have to look the same. They have to be the same. This second equation says that negative 6x plus 5y is exactly the same number as 3. That makes it okay for me to add negative 6 plus 5y to the left side of the first equation, while on the other side of the equal sign I can add 3 and 3. It's okay to do this because negative 6x plus 5y and 3 are exactly the same number. So I'm adding the same number to each side. Now I know they don't look the same, but the equal sign says they are the same. We can use that to our advantage. So, on the left side, 6x plus negative 6x, gone. Those 2 things cancel each other out when you add them. Negative 3y plus 5y, 2y. And 3 plus 3, 6. Now proceed with the basic steps we've used all year long. Divide both sides by 2. 2y divided by 2 is just y. And 6 divided by 2 is 3. We're halfway to the answer. Our goal was to find a point, and a point has 2 coordinates. We found the y-coordinate. How could we find the x-coordinate? Well, we can take y equals 3, substitute it into either of the initial equations. I'll substitute it into the first one. So we have 6x minus 3 times 3 equals 3. Well, 3 times 3 is 9, so I have 6x minus 9. Add 9 to both sides, and we have 6x equals 12. Divide both sides by 6, and we have x equals 2. So, our solution is 2, 3. And that's how we use the method of elimination to discover the intersection point of 2 lines. In other words, how we solve a system of linear equations in 2 variables. Again, the process is to find a way to combine the equations of the 2 lines so that one of the variables simply disappears from the problem. Solve the equation that remains for the other variable, and then take the substitution back into one of the original equations to find the remaining variable. Appearing on your screen now is the text of a word problem that we're going to solve using the method of elimination. Now, the wonderful thing about ShowMe is that if you touch the screen or click the screen right now, it'll pause for you. you need to write these words down so you know how to translate them. So, please feel free right now to pause the Show Me and write this entire problem down on a piece of paper or scratch paper somewhere so that you can follow along. Because when I show the work on the next screen, the text won't be there. So use this time, right now, to write it down. 3, 2, 1, pause. I'm assuming you just paused the Show Me and wrote down the problem, so it's now going to disappear from the screen, and I'm going to show you how to do the problem. Please follow along with what you wrote down. So having written the problem once, you're very familiar with it. You know that your class sold 48 tickets, but there are two different types of tickets. There are student tickets and adult tickets. Let's represent each type of ticket with a variable. Let's say that A is the number of student tickets that we sold, and B is the number of adult tickets that we sold. The first sentence of the word problem says that we sold a total of 48 tickets, regardless of type. Well, to get a total, we add. And the first sentence says that that total is 48. The number of adult tickets, B, plus the number of student tickets, A, is 48. The next sentence reveals how much we charged for each ticket, and the sentence after that talks about how much money we earned. Well, we brought in $126. That's a total. It's the total of the amount of money we brought in for student tickets and the amount of money we brought in for adult tickets. How much money did we bring in for student tickets? Well, we sold A of them, and each one costs $2. So the total amount of money that came in for student tickets was 2A. How much money did we make for adult tickets? Well, we sold B of them, and for each one we made $4. So the amount of money we brought in for adults was 4B. Now $126 represents the total amount of money. Again, we get totals by adding. And now we have two linear equations in two variables, the same two variables, both in standard form. It's time to use the elimination method. There's an important difference between this system of equations and the first one that I showed you. The first one had a ready-made elimination all set up for us. This one doesn't. We're going to have to do some work. Fortunately, we have a little rule called the multiplication property of equality. And it says that I can multiply each side of an equation by the same number and still have a true equation. The trick here is to play a game. I want to pick the right thing to multiply one of these equations by so that I have a ready-made elimination when I'm done. Well, I think I'd like to get rid of the variable A. Now that's a choice. I could also get rid of B, but I'm choosing to get rid of A. Now, in the first equation, A has a coefficient of 1, as does B. I want to turn that coefficient for A into something that will eliminate when I put it together with 2. Well, if I were adding 2 and negative 2, the A's would drop out. I could find out what B is. I think I want to do that. To do that, then, I have to take the first equation and multiply it by negative 2. And I'll write that result underneath the second equation. So, negative 2 is going to get multiplied by every single number in the problem. In truth, what I'm doing is I'm doing the distributive property on the left side and just multiplying 48 by negative 2 on the right side. So, negative 2 times 1A is negative 2A. That's good. That's what I wanted. I'll show you why in a minute. Then I have to take negative 2 times 1B, get negative 2B, and that's fine. Then on the right side, I take negative 2 times 48, and I get negative 96. Now that I have this new equation, I can eliminate the variable A using the same procedure I showed you before. The numbers, the two sides of the equation in the third equation, they represent the same number. Negative 2A minus 2B is the same thing as negative 96. So it's okay for me to add negative 2A minus 2B to the left side of the second equation, while I add negative 96 to the right side of the second equation. 2a plus negative 2a is gone. That is indeed what I wanted. 4b plus negative 2b is 2b. And then 126 plus negative 96 is 30. Now, I simply divide both sides by 2. b is 15. We sold 15 adult tickets. Well, how many student tickets do we sell? That first equation is very convenient. We know that we sold a total of 48 tickets. Well, if we sold some student tickets, and we also sold 15 adult tickets, and we sold a total of 48 tickets, then subtracting 15 from both sides tells us that we sold 33 student tickets. Does that work? Is it right? Well, to get our final answer, we use the first equation. So we know that our answer, 33 for A and 15 for B, is going to work in the first equation. We should test it then in the second equation. The second equation was 2A plus 4B equals 126. Let's put them in. 2 times 33 plus 4 times 15 needs to equal 126 for us to be correct. Well, 2 times 33 is 66. 4 times 15 is 60. And 66 plus 60 is indeed 126. So, our answer is correct. Of course, you need to write your answer. And the answer is that we sold 33 student tickets and 15 adult tickets. So, that's not only how to translate the problem, that's how to solve it using the method of elimination. The big difference between this problem, the procedure that we used, and in the original problem that I showed you, is that we had to create the situation where elimination would happen by using the multiplication property of equality. It is perfectly okay to do that, and it's a method you need to master. Again, the whole philosophy behind both the substitution method and this elimination method that we're talking about here is the idea that we're trying to set the dumpster on fire. We're trying to turn a complicated problem into a simpler problem, one that we've already mastered. Let's briefly run through one more example. I want to point out again that you can eliminate either variable here. The trick is to pick the path of least resistance. Find the easiest way to accomplish your goals. Your first goal is to eliminate a variable. We could eliminate x in this particular system if we wanted to multiply the first equation by positive 7 and the second equation by positive 2. That's two multiplications. Is it possible to eliminate a variable by doing less work? Yes, it is. I can take the second equation and multiply it by 3, and I can eliminate y. That's what I would recommend that you should do, because you need to keep things simple. The more elaborate calculations you end up doing to find your solutions, the more likely you are to make an error, and I don't want you to do that. So let's take the second equation and multiply it by positive 3. 3 times 7x is 21x. 3 times negative 5y is negative 15y, and 3 times 17 is 51. Now I can simply add the first and third equations to eliminate y. Negative 2x plus 21x is 19x. 15y plus negative 15y is gone, and that's what I wanted. Negative 32 plus 51 is 19. Well, if we divide both sides by 19, we find out that x is 1. Now we need to take that value and substitute it back into one of the two equations. Let's use the second equation. So I'm going to take x and put it in. So I'll have 7 times 1 minus 5y equals 17. Well, 7 times 1 is 7. Subtract 7 from both sides. You have negative 5y equals 10. Divide both sides by negative 5. It looks like y is negative 2. Now, I used the second equation to get that result. I should check my result in the first equation. So I should see what happens when I take negative 2 times my value for x plus 15 times my value for y. Well, negative 2 times 1 is negative 2. 15 times negative 2 is negative 30. And negative 2 plus negative 30 is negative 32. That matches what I was supposed to get. My answer is this solution, 1, negative 2. Remember that you want to find an efficient way to get your answers. There may be a time when you are forced to do 2 multiplications to get your eliminations. That's what you would have had to do to eliminate x first in this problem. But if it's possible to do it with only 1 multiplication, as it was with the variable y, I recommend that you should do that, because it keeps the number of steps you have to do to a minimum. It keeps your elaborate calculating out of the way, so you can focus on homing in on an answer quickly and efficiently. I hope this has helped you appreciate the method of elimination. It's the method that is most important for you to master if you intend to pursue a lot more advanced work in mathematics, because a lot of the work that you'll do in the future with matrices and computers will focus on the application of this method to more elaborate problems.